Now let's turn our attention to temporal analysis. Storms not only have a spatial pattern, but a temporal one as well. In this section, you will analyze the temporal pattern of storms on 22 April 2011. Sort the tornadoes attribute table on the Object ID field. Highlight the first few records in the table. And move the table so that you can see the map. See those cyan dots? Those are the ones we're looking at right now. Let's highlight a few more. Down here, and there's one up here now. Repeat this process for the next few records and so on until you are at the end of the table. Observe how the tornado touchdowns move as the day progresses. So here's the middle of the day. Now they're all up in here. There's a couple down in Oklahoma still. Of Missouri into Illinois and Indiana and Kentucky. Describe the movement of the tornado touchdowns as 22 April 2011 went on. Repeat this process for the wind and hail layers. Compare and contrast the movement of the wind and hail during 22 April 2011 compared to tornadoes. What was the primary direction that the storms moved that day? The times given in the data tables are in Zulu time, or Coordinated Universal Time. Let's take a look at this time scale right here. See the following table for converting UTC to the time zone in the central USA during the time of the tornadoes, Central Daylight Time, or CDT. Here is the conversion table that I was talking about. What was the range in hours from the first tornado to the last tornado that day? What was the 2-hour block that you would say encompassed the height of the tornado activity that day in Central Daylight Time? Can you find any single time where more than one tornado occurred? If so, how far apart were these tornadoes on the map, in distance? Do some research on the tornado at the St. Louis Lambert International Airport that occurred that day. Describe what happened during this tornado. Here is the tornado that we're examining right now. Main terminal windows blown out at Lambert Airport. Roof off of Concourse C, power outages. That's this one right here. Describe what happened during this tornado. Name some problems that could arise if a tornado happened at an airport, as it did here. Look at your data in your GIS. What time of day is indicated in CDT for the tornado? What was the latitude and longitude of the tornado? Describe the location of this tornado in relation to the pattern of the other tornadoes that day. And as you can see, there are others in that area. Describe any wind and hail events. Here's hail. Here's wind events that occurred near the location of this tornado that day. And resave your map document. Let's change our analysis now and examine some cities. Use the Measure tool to answer the following questions. How far was the center city of St. Louis from the airport tornado? What major highways was the St. Louis Airport tornado near? How far from the closest other tornado on this day was the airport tornado? What other major cities were there tornadoes near to on April 22, 2011? And you could examine the other ones that are close to cities on that particular day in April. So what we've done is we've analyzed tornadoes spatially and temporally. We've looked at the relationship between cities and tornadoes. We've also examined one particular tornado that caused damage at the St. Louis Airport.